Hello again from beautiful downtown Tashkent, Uzbekistan. I've had a few comments that really mention the fact that, in my first video, I talked about, listed, verified from third parties, and verified was against the standards. And a lot of you out there mentioned, standards. How do they, how do they come about? What's really a standard? So I thought that I would use today to try and enlighten everybody as to how and what are the important standards when it comes to structured cabling system. So we'll go into a little PowerPoint presentation that I've developed for that aspect. So let's get right into it. What is a standard? Basically, a document that is established by a consensus and approved by a recognized body. We'll go through that list in a short while. That really the end goal is to provide a common and repeatable use or rules, guidelines, characteristic for an activity or product. And the result is achieving the optimum degree of order. In my case, I'll say performance in certain aspect of it. So, as you can see, when it comes to standard bodies, some of them might look familiar to you: TIA, IEEE, BICSI, nonprofit organization. Most of them are nonprofit. Basically, a lot of the members are volunteer from either very large user group, governments, manufacturers, naturally. All these people are members of these bodies or organization, and together they'll sit down and hash out a standard. So why so many? Well, you have to understand that some of them are going to be country oriented. Selenek is a very good example since it's really targeting European nation. Others are industry oriented, automation control like Profinet, Profibus. But others, probably more familiar to you, are got a greater audience because they're worldwide basis, like ISO and IC, TIA, BICSI, IEEE more for the electronic side of the business. So one big question is there a benefit to having a standardized product or methodology? And the simple answer is yes. Come on. When you think about it, everybody does it the same way. So I own a multinational corporation, for example, and I have offices in Moscow, I have offices in New York, I have offices in Hong Kong and Sydney, Australia. The thing is that if my tech people know the methodology and the product, because it's used in the same method all over the world, it makes everybody's life a lot easier. So standardization is a big benefit, especially when you're looking at today's basically globalization. The world is getting small. So how is a standard created? Well, first they'll find that, there's something new out there, so they'll define a scope and what they intend to achieve, and they'll get all the different people sitting at the table to have discussions. Compromise is a big word in here because you have big players, medium-sized players, and big players, and naturally, some of them have to compromise because some players will say, no, I can't do it that way, or you need to do it, or whatever. Consensus will be the end. I'll come back to that. So they'll all agree on the content after that, prepare the draft, agree on the draft, and then finally, sometimes years after the fact, they'll publish the standard. So for me personally, a big word in the standard is consensus. You have to understand, sitting at a table, it doesn't matter if you're talking about TIA, ISO, IEC, it's made up of the players, the people who are involved in this. There's some big players, small players, and everybody's got to agree. It's not a majority. The standard will be published only if there's a consensus amongst all the players, small, large, medium. So in this case, it's a compromise. So what does it mean in the end? That sometimes the standard is just the minimum that everybody could agree on. You know, it's not the best. It's just something that every member of the organization or the committee or TR or whatever we're sitting on could agree on. So for structured cabling system, is it important? Well, over the years, just like the industry, the standards have evolved. And some of them now are more specific to each marketplace. It means that some standards now are directly aimed at data centers. Some are commercial building, industrial application, hospital. Even some of the standards now are even aimed at application, you know, automation, building management system, BMS, or even some newer ones lately with power over Ethernet and plus, and all that nice song and dance. So how many standards there are there? There, excuse my language, there's shitloads of standards out there. You know, as an example, I'm using the Big C's 14 TDMM edition. It has 2,200 pages. And keep in mind that it doesn't include the standards. It only references the standard where it applies. It doesn't include them. So this is just 2,200 pages of information, very valuable and good information, but the standards are not there. It'll reference either 568B, 569, 11801, whatever the case may be, okay? So definitely, I won't have time to go through them all right? Also, sometimes, regionally speaking, you might want to have this particular standard versus another because of the region you're operating in. But importantly, there are basically the same. There's very small differences. Example, as I used here in the slide, is that power sum ACR, okay, the attenuation to crosstalk ratio, is defined in the ISO 11801. But in TIA 568D2, power sum ACR is not. You'll find PSACRF from the far end, but the strict value of power sum ACR is not defined in 568. So it's a very little difference anyways. So let's take a look really per marketplace. We can take a look. Data centers are big. So completely on the left-hand side, you'll see that you have TIA 942B, 24764, Celanec 5173-5, Big C002, a ASHRAE, which is more in regards to heating and cooling issues, power, the 606 administration, labeling, administration of the structure itself, the infrastructure. Big C009, a new publication, really relates, I put it in there because it deals with data center, but really deals more with the operation and maintenance of data centers. When you're looking at commercial buildings, you'll look at 568D and its three variants, 0, which is just basically the generic, section 1, which deals with the cabling standards, section 2 will deal with the twisted pair or copper, basically cabling and components requirements, what it needs to be able to meet to call itself a Cat 5, Cat 5e, Cat 6, Cat 6a. In regards to D, section 3, it relates more to the fiber optic components. This is really towards commercial buildings. So this is probably one of the most important ones when you're looking at strictly commercial side of structured cabling system. That's why it's up there in front and center. But there are many others regarding earthing and grounding. Healthcare facilities have their own standards now. Pathways and spaces have their own recommendation. Let's keep in mind standards are recommendation. They're not the law, but they're good recommendations on what you should do to have benefit for the end user of the system once you've done it. Industrial sites, even the installation practices used by the installers have their own recommendations. And even now, cabling testing, either be copper or fiber. And I noticed over the last quarantine periods of COVID-19, Fluke has been doing a lot of webinars about that. So hopefully quite a few of you have caught some of those good webinars. And this is just to name a few. There's so many of them out there that you need to be aware of. So standards, you got to understand they're our friends. They'll allow you to design, install, and test to be the same, either be for national, international, or worldwide level for any organization out there. So what's done in one place, it's the same thing as it's done in another place. But one big point that I'd like to, make sure I stress, everybody's familiar that when somebody says you meet the standard, don't brag about that. Okay, because the standard is a minimum that was achieved by consensus of all the members of the organization or the work committee that established that specific standard. Okay, so it's the minimum. I'd rather see somebody say that you meet and exceed the performance specification of the standard. One bigger question for a lot of designers and installers out there is, do you really understand all the performance parameters that are in these documents, in these standards? And, insertion loss, power sum ACR, all these things, attenuation, backscatter, reflectance, all these terms. Do you know what actually it means when you're reading it? So we'll talk about that more in my next presentation. Hopefully the information that you have just watched or listened to has been useful. So that's my goal. Knowledge is power. And as I mentioned at the end of the PowerPoint, I will be looking into the parameters, really the testing and performance parameters that everybody should be really familiar with and aware of what action they might take during the design or the physical installation that actually might impact the performances of those components. So stay tuned. If you appreciate it, thank you. If you didn't, thank you anyways. As I said before, appreciate any comment, good, bad, I can handle it. Take care and see you soon.